Hello, hi everyone, it's Ian here again for Crack Maths. Welcome back to part 2 of today's sessions, which are the exam paper Thursdays, where in the first half of today's session we looked through what was it? Always getting the sound check there. Where we looked through part 1 of an Edexcel paper, and we actually got up to, in fact, let me just go back to the start just to show anyone that's joining now the paper that we're doing. We are doing, this is the paper that we have. Oh, here we go. It's an Edexcel Functional Skills Level 2 past paper, paper 3. So you'll be able to find the video from earlier if you're just joining us now, where we looked at the non-calculator section and then the first few questions of the calculator section. Now, in this section, we're going to start off with question, I think it was here, where were we? Yes, question 3. Okay, so, or question 4, let me have a look when it loads up. Great, question 4. So, anyway, let's start by having a read through what this is saying. So it says here that Anwar makes a playhouse for his children. The front elevation of the playhouse has one line of symmetry. Okay, so just to let you know, the front elevation means the view that you see from the front. So I'm going to shade that in. So that would be this bit here. So this is going to be the front elevation. Okay. And one line of symmetry, the significance of that is it means that this bit here is going to mean that this peaks in the middle, okay? So the point of the triangle is going to be exactly in the middle. So the question asks us here, it says, draw the front elevation of the playhouse on the grid. Use the scale 1 to 20. Okay, so let's have a look at that scale here. So this means 1 to 20, and it doesn't have any units with it. So what it means is that it's referring to the same units in each part. So it will be 1 unit, so for example, 1 centimetre on the drawing is 20 centimetres in real life. Okay, so what we're going to have here, we're going to split our scale up. So we've got 1 to 20. Okay, and this bit is going to be our drawing. And this bit is going to be real life. Okay, so I can see here some measurements for real life. So let's start with this bottom one here. Let me move my calculator. I always get it in the way. There we go, let's put it over here. So the 20 is the real life and the 1 is the drawing. So let's start converting some of these. So I can see that the width of this playhouse in real life is this bit here. It's 100 centimetres. So that's a real life measurement. So I'm going to put that directly under here. So I'm going to put 100 centimetres under here. So now what I need to do is I need to know, what do I do to get from 20 centimetres to 100 centimetres? So what am I timesing that by? So remember, in functional skills maths, we have a thing called, well, in maths in general, we have a thing called a reverse calculation. So if I know that 20 times something equals 100, okay, I can find out what that something is by doing 100 divided by 20. Okay, so let me have a go at that there on the calculator. So here we go, 100 divided by 20, and that equals 5. So I know that 20 times 5 gives me 100. So I want 5 lots of 20, so I'm going to want 5 lots of 1. So if in real life the line is 100 centimetres, on the drawing it's going to be 5 centimetres. Okay, so I'm just going to put 5 centimetres here. Okay, now let's have a look at some of the others. So the other one, remember, we've got 1 to 20 again. And now here we need to work out, well actually, interestingly enough, we've got this bit here, which is that length here, is going to be the height because if I move that around here, what we'll see is that bit is from there to there. So I know from here to here is 110. So I'm going to put that down there, 110 centimetres. So I've put 110 centimetres there, and then that means that the bit from here to here is going to be, well, if we know from here to here is 130, I literally can't get this calculator in the right position. Let me move it over here. Let me just move it off the screen when I'm not using it. Okay, so what we've got here is we've got, if this bit is 130 and here to here is 110, this bit has to be 20 centimetres. And I worked that out by doing 130 take away 110. And I know that that equals 20. Right, oh, which incidentally, I know straight away that 20 centimetres is 1 centimetre. So I can say that this bit here, the peak, is going to be 1 centimetre. Okay, and now what I've got to look at is, I've got to look at this last one here, which is 110. So let me just move this bit of information over here. I'll just put that over there as that's banked working out. So what we've got here is I'm going to put underneath 110. Okay, so we know that the scale is 1 to 20, but we want to find out what it is when it's 110 centimetres in real life. So we need to know, what do we times 20 by to get to 110? So let's do, again, our reverse calculation. We have 20 times something equals 110. So 110 divided by 20 will equal that something. And I'll bring my calculator back. Okay, I'll put it over here now. So here we go. We've got 110 divide 20, and that equals 5.5. So that means we've times that by 5.5. So we're timesing this by 5.5. And then, so we know that that length here will be 5.5 centimetres. Okay. So now we've got all our information, we can put this on the grid. So let's start with the 5 centimetres. So 5 centimetres is going to be 5 squares. So 1, 2, 3, 4, 5. Okay. Then 5.5 centimetres will be 5.5 squares. 1, 2, 3, 4, 5.5. Ooh, I've been dicey with this. Is that 5.5? 1, 2, 3, 4, 5, 5.5, yep. And then here we've got 5.5 as well. And then there's a line that joins those, just incidentally. We'll need to put that on there because that'll be important. And then the last bit is 1 centimetre. So, and it's got one line of symmetry. So the peak is going to be 1 centimetre up and in the middle. So I'm going to put that over to here, to there like that. And I'll put this line over here. And there we go. So it looks a little bit weird, doesn't it? Because it doesn't look like this. But let's just double check. So 100 divided by 20 is 5. 110 divided by 20 is 5.5. 1, 2, 3, 4, 5. 5.5. Yeah. 20 divided by 20 is 1. Yeah. So there we go. We've got there the front elevation of the playhouse. So that is that done. Right. Okay. And you can see the line of symmetry. It will be down the middle. But you don't have to put that on. That's just kind of there for information purposes. Okay, great. Right, so the next topic we've got here is we've got mean from a grouped frequency table. I think this came up in the last past paper that we did last week as well. So it's clearly something that we're looking at all the time. Oh, and also it came up on the averages session that we looked at on Monday. So hopefully you might have a go at an idea about what we're going to do with this one. But if not, let's just take a quick recap. So first of all, I'm going to read through the question. So the question says here, let me move the calculator out of the way. If I put it up in that top corner, it should be all right for this one. So here we go. So we've got here, in October, Mr. Barker gave a group of 250 students a history test. Okay, that's useful. 250 students, so we know that this bit that says frequency is going to add up to 250. So all of this frequency here will refer to the students. Okay, these are the results. So we've got here number of marks, frequency. So the frequency means the number of students that got those marks. So we've got 20 students that got between 1 and 5 marks, 50 students that got between 6 to 10 marks, 120 students that got between 11 to 15 marks, and 60 students that got between 16 to 20 marks. Okay, so let's have a look at the question. It says, Mr. Barker estimates the mean to be 12. Is Mr. Barker correct? Show why you think this. So what they want us to do is they want us to very specifically estimate the mean in the way that we've been taught to estimate the mean. Now, remember, the reason why it's an estimate, it is nothing to do with rounding. It's simply about the fact that we don't know what score any of these students got. So what we're going to have to do is make a guess. So, how do we make this guess? Well, the way that we make the guess is that we actually take the average of the 2 points of the interval. So if we know that this person got between 1 to 5 marks, we work out what is the midpoint of that. And the way that we do that is we're going to do the first number, 1, add the 5. We'll find out what that is. So in this case, that's 6. And then we do that number divided by 2. So 6 divided by 2 is 3. Okay, so I'm going to put 3 here. The next one is here. So I could do this on my calculator as well. So let me have a go on my calculator just to make that easier. So the next one here, we could do 6, add 10. Remember to press equals at this point, because if you don't press equals right now and you just went into doing divide by 2, what it would do is it would do 6 add 10 divided by 2. Okay, so it would do the 10 divide 2 first, and then it would add the 6. So that would be a very different calculation to 6 add 10, and then all divided by 2. So 6 add 10 equals 16. And now 16 divided by 2 equals 8. So our estimate for the number of marks that these 50 people got is 8. Right, let's look at the next one. So the next one, we're going to do 11, add 15, and that equals 26. So 26 divided by 2 is going to be 13. So that's our estimate for those. Now, have a quick think about this last one and see if you can think about what your estimate's going to be for that. I'll give you a quick moment. I'm going to take a quick drink. And then, so let's have a go. Hopefully you did 16 add 20 to get 36, and then you divided that by 2 here. Okay, and that's 18. I meant to say, if you are able to do any of these questions quicker than me, please do them along with me, and then write your answers in the comments, and then you can find out if you've got it right as the video goes on. It's a good way of checking your knowledge to see how well you're doing. Right, now, I'm just going to do a quick recap. The mean, in general, is equal to everything added together divided by the number of things. And in this case, it's all the scores, all the marks even, all the marks, divided by all the students. So what we need to do now is we need to add up all the marks. So if 20 people got 3 marks, we can times these together to say that altogether they got 60 marks. If 8 people got 50 marks, if 50 people got 8 marks, we can do 50 times 8. And so we can say all of these people collectively got 400 marks. Now, if we've got here 120 people gaining 13 marks, we can do 130 multiplied by, no, I've gone wrong, 120 multiplied by 13. And so we can say that all of these people got 1,560 marks. And then lastly, we can say that we've got 60 people that got 18 marks. So what I'll do here is we've got 60 people times 18. So collectively, they all got 1,080 marks. Right, what I'm going to do now is I am going to add all of these numbers together. So we've got 1,080, add 1,560, add 400, add 60. Okay, so altogether they got 3,100. So remember our formula here, all the marks over all the students. So the mean is going to equal 3,100 divided by 250. Okay, so let's work out that. So here we go, 3,100 divided by 250. Okay, now remember, it's really important which way round you write these numbers, but there is a way to check if you've done it the right way, and I'll talk about that in a second. So the mean here is 12.4. Okay, now if we look at our mean, 12.4, this makes a lot of sense for this data, okay, because we can see that the highest mark was 20, the lowest mark was 1, okay, so it's likely that the mean is going to be between those. Well, 12.4 is between them. Mr. Barker estimated the mean was 12, so 12.4 is close to that. So actually we could say that Mr. Barker is correct. In fact, let's say that now. Okay, so let's say, yes, Mr. Barker is correct. In fact, I'm going to say he's correct to the nearest whole number. Because you wouldn't get part of a mark anyway, to the nearest mark. Okay, so yes, Mr. Barker is correct to the nearest mark. But back to how we could see what would happen if we'd done this. If we'd accidentally done this division the wrong way round, 3, 1, 0, 0. Oh no, I'm doing it the right way around again. If I'd done 250 divided by 3, 1, 0, 0, what we'd get is we'd get this. And what we can see is that this number wouldn't make sense in the context of the question. Okay, it wouldn't be possible that the mean number of marks was 0.08. And so whenever you do a division, it is worth just checking. If you're not confident about which way round it always goes, it's always worthwhile having a think about if your answer makes sense. Right, let's get on to the next question. Okay, well this is a part A, so there's going to be a part B. So here we go. Right, so here's part B, and part B says, in the October test, the lowest mark was 2 and the highest mark was 17. In November, the same students took a similar test. The lowest mark was 5 and the highest mark was 18. Mr. Barker wants to write a statement comparing the spreads of the marks in the two tests. Write a statement to compare the spread of the marks in the two tests. Show the calculation. So spread refers to range, okay? So spread means range, okay? And range is the highest, take away the lowest, okay? And also, a good 2 points to remember is a low range means consistent data, which means everyone's getting roughly the same thing. A high range suggests inconsistency. Okay, so for example, if you were taking the results of somebody, I don't know, doing something, let's say somebody took a test actually, and they got a high range, that would mean sometimes they'd scored a lot of high marks and other times they'd scored a lot of low marks. But if they had a consistent range, if they had a low range, that would mean every single time they got roughly the same score. Okay, so it means that if you have a low range, you can kind of count on the results that you're getting. You can use those results to predict the future. But if someone's got an inconsistent range, if someone's got a large range, it means that the mean or the average or the median, it doesn't necessarily tell you much about the data. Anyway, let's have a look at how we can use this information to compare this data. So let's have a look, and it says, so let's first of all do October. Okay, so the October range is going to be 17 take away 2. Okay, so 17 take away 2 is 15. Okay, now let's do the November range. Oh. Okay, I'll leave you a quick moment to think about what it's going to be, and then I'll write it down as well. Okay, so what I've done is I wrote 17 take away 2 for the October range. So the October range is 15. And the November range was 18 take away the lowest mark of 5. So that gave us 13. So therefore, what I could say is that the results in October had a larger range, and therefore, oh, that's not how you write therefore. Therefore, were more spread out. Okay, great. Right. Let's now look at the next question. So here we go, question 6, and it says here that Mia is the manager of an ice cream shop. In August, she sold 960 lollies. In September, she sold 810 lollies. Did Mia sell 18% fewer ice lollies? Oh, Mia thinks she sold 18% fewer ice lollies in September than in August. Did Mia sell 18% fewer ice lollies in September than in August? Right, okay, so what it sounds like we've got to do here is, if we know that she sold 960 ice lollies in August, it seems like what we've got to do is reduce that by 18% and then compare that to the number of ice lollies she sold in September. So remember, if we're reducing something by a percentage, we always start out with 100%. So if I have 100% and I want to reduce it by 18%, okay, to find out what an 18% reduction would be, that means that I'm going to be looking for, well, let's do this on the calculator, 100 take away 18. So that means I'm going to be looking for 82%. Now, if I want to find 82%, what I've got to do here is my percentage fraction decimal equivalence. So I'm going to have to turn my percentage into a decimal, and then what I'm going to have is a decimal multiplier where whatever I multiply by this decimal will give me that 18% reduction, or we could call it 82% of the value. So to go from a percentage to a decimal, I do 82 divided by 100. So 82 divided by 100 equals 0.82. Okay, so I now know that anything multiplied by 0.82 is going to reduce that value by 18%, okay? Because a reduction of 18% is 82% of the original value. So if I now do 960 multiplied by 0.82, this is going to give me the 18% reduction. So let's try here. 960 multiplied by 0.82, and that equals 787.2. So an 18% reduction in the number of ice lollies sold in August would be 787. Oh, so Mia hasn't done as badly as she thought. It's only reduced, 18% reduction would be much larger. So no, she hasn't sold 18% fewer lollies. She has sold less, but she hasn't sold as many as 18%. And we can just say here, no, an 18% reduction would mean only selling 787 lollies. Okay, great. Right, let's move on to the next question. Ooh, what's going on here? Right, so let me just roll this question up a little bit. So here we go. This question says, Alex has 2 sets of 4 cards. He writes a number on each card. Alex picks 1 card from each set and multiplies the numbers to get a score. The table shows some of the scores. So here we go, we've got some of the scores here. And they've filled in some of them. And they're asking us to complete the table. Okay, right, so now this is a bit of a funny one because it's negative numbers. So the rules of negative numbers are, if you have 2 negatives multiplied together, that will make a positive. If you've got a positive multiplied by a negative, that will be negative. Well, and that's it really. If you've got a positive times a positive, that will be positive, but we know that because that's just normal. So let's do the first one. So the first one here, we've got 2 times negative 9. I can actually even do it on my calculator. So 2 times negative 9, and that will be negative 18. Okay? And remember that follows this rule here, because a positive times a negative is negative. Let's try the next one here. 4 times negative 5. So 4 times 5, and then let's make it negative. And that's going to be negative 20. Oh. Then we've got here 4 times 11. The 11 times table is always a nice one, so that's just 44. Here we've got negative 6 times negative 9. So let's do this again. So negative 6 times negative 9, 54. And then we've got negative 6 times 11. So let's just do that up here. Negative 6 times 11. You should never be afraid to use your calculator in your calculator exam because you have it, because it's there, and we always have calculators really. So when we have the non-calculator exam, it's really a bit of a funny situation. So always feel comfortable using your calculator. Here we go, we've got 8 times negative 9. So here we go, 8 times 9, let's make that negative. So that's minus 72. And then lastly, we've got 8 times 11. Well, I know that is 88. Right, perfect. So that's that done. Now let's look at what the set. Oh, there's quite a lot of parts to this question. So let's have a look at this second part here. So Alex says the probability that the score is negative is 0.5, which means that there is a 5% chance of getting a negative score. Okay, right. So Explain why Alex is incorrect. So Alex is incorrect because if you want to go from a decimal to a percentage, you multiply by 100. Okay, so to change from decimal to percentage, multiply by 100. Alex has multiplied by 10. Okay, there we go. Right, let's have a look at this last bit. I want to keep that on the screen though. So Alex picks one card from each set. What is the probability that the score is 14? Okay, so here we go. We've got to identify all the scores that are 14. And for me, I think I can only see that it could be this one. Okay, which means that that's one score, okay? One score out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So that's 1 out of 16 because he only had one chance of getting that score out of 16. Okay, right. Let's have a look at the next one. So here we go. Oh, we've got a shape. That's nice. Okay. Abby has a mirror in the shape of a rectangle with a semicircle on one of the shorter edges. The radius of the semicircle is 30 centimetres. The radius of the semicircle is 30 centimetres. The longer edge of the rectangle is 85 centimetres. Abby buys 500 centimetres of length of mirror trim to go around all the edges of the mirror. Okay, I see what she's doing. So she's putting mirror trim all around the edge of the mirror like this. Okay, she thinks she will use 2/3 of the length of the mirror trim. Okay, so she's bought 500 centimetres. She thinks she's going to use 2/3 of that. Is Abby correct? Show why you think this. Okay, first of all, let's find out how much 2/3 of the mirror trim is. Remember, with these questions, especially questions that are like a lot of marks, you don't need to get it all. Well, it's good to get it all right, but you don't necessarily, if you can't do it all, it doesn't matter. You just still need to do what you can, okay? So I think the first thing that we could do is we could find out what 2/3 of this mirror trim is. So let's have a look. So I know that 3/3, which is the whole of the mirror trim, is 500 centimetres. So if I divide that by 3, I get 1/3. So 500 divided by 3 equals this, 166.6 recurring. And then if I times that by 2, I'll get 2/3. Okay, so there we go. So 2/3 is 333.3 centimetres. Okay, so we know how much 2/3 of the mirror trim is. Right, when they talk about the radius refers to, what's that? Actually, I don't know what I did there. The radius refers to this line here, okay? And you might be able to spot this, but this line here is half of all the way across, okay? So the radius is half of what they call the diameter. So, one sec. I didn't mean to do that. So if the radius equals 30 centimetres, the diameter equals 60 centimetres. Okay, so I know that if this is 85, I know that this from here to here is 60. It's a rectangle, so that means that the opposite lines are the same size. So from here to here, on this side, will also be 85. And so the last thing we need to do is find out this distance around the top. Okay, so we've got here, well, in order to do that, we need to know the formula for the circumference of a circle. So if I just, actually I could do it here. If I think about a whole circle, with a diameter of 30, the way that I would find the circumference, which is the name for the distance around the outside, would be by doing this formula here. So circumference equals pi times 30. Now, in functional skills maths, we always use pi is 3.14. So the circumference will equal 3.14 times by 30. And I said that's the formula. The 30 is the diameter. So the formula is pi times diameter. So in this case, it's going to be pi times 30, which is 3.14 times 30. So I'm going to do that on my calculator. 3.14 times 30. And that equals 94.2. But that is all the way around. And we only want to go half the way round. So we're now going to do 94.2 divided by 2 to see where that gets us. So 94.2 divided by 2 equals 47.1. Okay, so that distance here from here to here is 47.1 centimetres. Now what we do is we just need to add it all together to find out if it does use 2/3 of the mirror trim. Okay, so let's get these numbers together. So we've got 85. Okay, I'll put a tick here. In fact, I'm going to write them down just in here when I add them together. So we've got 85, add 60. So I'll add that on, 60. Okay, so we've done this one, we've done this one. I'm going to add another 85. So that's this one here. Okay, and then 1, 2, 3, I've got to add this 47.1 on, so I'll add that one on as well. So add 47.1. So add the 47.1. I think she's going to comfortably do it. Right. So that equals 277.1 centimetres. So yes, she can do it. Abby is correct. She will use... Oh no, she's not. She's wrong. She's wrong. Abby thinks she'll use more than the 2/3 of the length of the mirror trim. She isn't. She's going to use less. So, which is lucky because it doesn't matter if things go wrong that way. But we're all right. So, no, Abby is wrong. She will use only 277.1 centimetres of mirror trim, which is less than 2/3 of 500. Okay, great. Right, let's have a look at the next question. Right, okay, here we go. We've got a grid. So on this grid, it says, Carl plots 3 points on a grid. Write down the coordinates of the point P. Okie dokie, so here we go. We've got the point P over here. And what I can do is, remember, whenever we write coordinates, we always write them down X and Y, like this, X, Y. It's alphabetical, X goes first, then it's Y. So we look for the X coordinate first, so I can see that this one has an X coordinate of 4. And then we look at the Y coordinate second. So I can see over here, this is on the line Y equals 6. So the coordinates for point P are going to be 4, 6. Okay, let's see what they say down here. Right, Carl plots another point. He joins the 4 points to make a parallelogram. Okay, so a parallelogram is one of those shapes that looks like, that doesn't look like this. It looks like this. So it's like the pushed over rectangle. Okay, so here we go. That is what a parallelogram is. So Carl plots another point to make a parallelogram. Write down the possible set of coordinates for the 4th point on the grid. Okay, so I'm just going to highlight these points here just so they're a bit more visible. Okay, So, in fact, let me join them up. I think that's probably the best thing to do. I'm going to join them up, and let me just make that a bit thicker. So here we go. So far, we've got a line from here to here. And what I'll do is I'm going to join this line from here to here as well. Right, so if I want a parallelogram, I need the opposite sides to be going in the same direction. So what I need to do is I need to think about this line here. I mean, this is actually really convenient for me because I can just, you can't do this, but I can just copy and paste this. So here we go. If I do that there, I need this line to look exactly like this, but be over here, because that's what parallel means. Parallel means going in the same direction. So I can actually put this line up here. And then what I can do is I can join these two. And I can see that I've got a parallelogram. Now, you can just play about with this. Remember to use pencil to start off with. Because if you get it wrong, you can then just rub it out and start again. But largely, just have a look to see when you're drawing the lines if they're parallel. A key clue could be is if you've got a triangle like here, can you reinsert this triangle of the same size? So in this case, height 1, width 3, up here. And if you can, that means that those lines will be parallel as well. Right, but the question is they want the point. So here you go. The point of this point is 7 on the x coordinate and then 5 on the y coordinate. Okay, great. Right, let's have a look at the next question. Okay, so here we go. We've got question 10 here, and it says, Andy and his brother set up 2 eco cabins. It takes 2 of them 6 days to set up 1 eco cabin. A friend starts working with them. How many days will it take 3 people to set up 1 eco cabin? Ah, okay. Right. This is, by and large, everyone's least favourite type of question. Okay? There's something about it that makes it really difficult to understand. But what we have to do is we have to think about how long would it take for one person to set up an eco cabin. So remember, one person is going to take more time to set up the eco cabin than 2 people. And 3 people are going to take less time to set up the eco cabin than 2 people. So what we do is we always start with, so if I know that 2 people take 6 days, and what that means is that we've got both the people working 6 days. So I've got one person here doing 6 days, and I've got one person here also doing 6 days. So altogether, they are doing 12 days of work. Okay, so this is the key to this question. You've got to remember that the 2 people are both working for 6 days, which means altogether they're collectively putting in 12 days of work. Now, if we share that 12 days between 3 people, we get how long it's going to take 3 people. So if 2 people take 6 days, we know that one person would take 12 days, because there's 12 days of work. And then if we want to find out how long it would take 3 people, we can do 12 divided by 3. I could do that up here. 12 divided by 3. And that equals 4. Okay, so 3 people would take 4 days. Okay, and that's how we would solve that question. Okay, right, I'm running out of time there for today, but thank you very much for watching if you've watched this far. If you've got any questions, any comments, anything you'd like me to cover more of, please leave comments in the chat or in the comments. Yeah, I'll be happy to help. And I'm also looking at my programme for the new year, so anything that you want me to make a plan to cover, I will be more than happy to accommodate that for that. If you need any other help, remember there's loads of work on this sort of thing on crackmaths.co.uk. And And yeah, this topic that we've just done was called indirect proportion, and you'd be able to find that there. But otherwise, have a lovely rest of your evening. And remember, if you're about at 11:15 tomorrow, come join me because I'll be looking through questions to do with volume. Okay, great. Thank you very much and goodbye.